the Pythagorean Theorem, you guys should be familiar with the Pythagorean Theorem from, I believe y'all start doing it in 7th grade, definitely 8th grade. And so guys, but we are going to talk about this specifically in regards to radicals. So guys, you use the Pythagorean Theorem to find the missing side of a right triangle. And guys, what makes a triangle a right triangle? Yes, that has that one lovely little angle that is 90 degrees, okay? And so how that's denoted in a triangle is with this little square in the bottom, okay? If it doesn't have the square, you cannot assume it's a right triangle, okay? It has to have that little symbol there for us to know that it's a right triangle. And sides A, I'm going to do that in my lovely little pink color here, and sides B are called the legs of your triangle, all right? Those are your legs. And then side C here, does anybody know what we call side C? Hypotenuse, yes. So guys, the hypotenuse of your right triangle is always going to be opposite of the right angle, okay? The hypotenuse is the longest side, but really the best way to identify that is by seeing that it is opposite of the right angle. So what I like to do is I like to draw a little arrow out of my box and circle it because that is my hypotenuse. And guys, the Pythagorean Theorem, the formula for that will be a squared plus b squared is equal to c squared. Is that ringing any bells, y'all? A squared plus b squared equals c squared. So we are going to take a look at a couple of these examples. I'm going to ignore this one for now, okay? But we're going to take a look at a couple of these examples. So we are going to use our lovely Pythagorean Theorem. And as I also wanted to let y'all know here, C is always your hypotenuse. I think that's where people get tripped up the most. And guys, that's why I look at it and say that it's opposite of the right angle. All right, the symbol for angle is that little guy right there. Okay, if you draw a little, like, I guess, I don't know, it's an angle. All right, it's not quite a less than sign. So it's always opposite of that right angle. Are you guys comfortable with that? So in this case, we want to find our value of x. So the first thing, guys, I like to do is label my sides. We have A, we have B is 7, and then 9, that is going to be our C because it's opposite of the right angle. Do y'all see that? That's going to be our C right there. So we are going to write this as x squared plus 7 squared is equal to 9 squared. Are you guys comfortable with that? So now, how are we going to solve for x? What should we do? Let's set it up, right? So let's actually multiply it out. So that's x squared plus 49 equals 81. Because 7 squared is 49, 9 squared is 81. If you need your calculator to figure that out, that's okay. But I just want to show y'all this here. So now, how do we get x squared by itself? What should we do, y'all? Yeah, subtract 49. So if we subtract 49 from both sides, we are left with x squared equals 32. So now, if I take the square root of both sides, I am left with x is equal to the square root of 32. That's not a perfect square, is it? But can we simplify the square root of 32, y'all? Yeah. Yes, we can. It's like all that stuff I was reminding you about. So guys, the square root of 32 can become 16 times 2, right? What's the square root of 16, y'all? So that becomes 4 square root of 2. So x is equal to 4 square root of 2. Are you guys comfortable with that? Do you see why it's so nice to know how to simplify radicals now? It's like all I was doing. It's like it mattered. Okay? Then we have 8 and 13. Interesting. So on this second example here, guys, we have 8 is one of our legs. 13 is another one of our legs. And guys, in this case, our unknown is the hypotenuse. It is that x squared because it's opposite of that right angle. So this becomes 8 squared plus 13 squared is equal to x squared. Are you guys good with that? Then this becomes 64 plus 169 is equal to x squared. Well, guys, 64 plus 169, a little mental math here. That would be what? 233, yes? Ugh, that's kind of an ugly number. So that's 233 is equal to x squared. We're going to take the square root of both of those. So the square root of 233 is equal to x. Well, y'all, can we do anything for 233? Can we simplify the square root of 233? I'm going to be honest. I don't know. I don't know the factors of 233 off my head. So that's where you go to that y equals 233 divided by x. I go to my table, and I'm trying to find a perfect square. Does it look like anything's going to work here? No. It's very sad. I guess it's a prime number. So there are no whole numbers other than 1 and 233. Well, so I mean, that is a bummer, but that also means that we're done. So that is your final answer. That's square root of 233. Are you guys comfortable with that? And guys, I would always go ahead and make sure to actually make sense. The square root of 233 is 15.26433. Is that longer than 8 and 13? Yes, it is, because it's the longest side. Does that kind of make sense, guys, as you guys are going? Awesome. All right, I'm going to do 2 more with you guys. I'm going to do number 1 and number 4, and I'm going to let you guys do the rest of them on your own. And then the back of this page has some mixed practice, okay? So, guys, we have 8 and 4. So the 4, I like to pick the smallest one as my A, but, guys, A and B are interchangeable. So that's 8 and 4. Those are my legs. And my x is the x squared there, all right? Or that's our hypotenuse, okay? So that this becomes, if we set it up, 4 squared plus 8 squared is equal to x squared. Are you guys good with that? And then we say, okay, well, that's 16 plus 64 is equal to x squared. So 16 plus 64 gives us 80. So 80 is equal to x squared. So I'm going to take the square root of both of these. So now x is equal to the square root of 80. Are we done? Can we simplify the square root of 80? Yes, and if you're like, I'm not sure, that's where you can use this lovely little trick where you can do the 80 divided by x. And you can say, cool. Well, what is the largest perfect square that is a factor? 80 is not perfect, 40 is not perfect, 20, 16 is perfect. So it's 16 and 5. So we are going to write that as 16 times 5. You can pull your 16 out, so that is 4 square root of 5. So your x is equal to 4 square root of 5. And just to make sure we're on the right track here, 4 times the square root of 5 is 8.94 something, something, something. So that is bigger than 8. So we know that we did it properly. Do y'all feel good about that? So on the top here, numbers 1, 2, and 3, the unknown is the hypotenuse every time. On numbers 4, 5, and 6, the unknown is one of our legs. So in this case, we have 7 squared plus, it even tells you, b squared And that is equal to, I like to draw my little arrow, so I know that is my C, is equal to 25 squared. So that would turn us into 49 plus B squared is equal to 625. Oh man, I kept the colors. I don't know what I was thinking. All right, you guys good with that? So now, how do we solve for B squared, you guys? What should I do? Very good. We're going to subtract that 49. And that's going to give me B squared is equal to 576. So now, I take the square root of both sides, and my B is equal to, well, you know, I mean, you can check it out, 576, oh, not 573, that is not a good number. Let's try it again. If you type in the wrong thing, it's going to give you the wrong answers. Guys, is that a nice, pretty whole number? It sure is. So your B is equal to 24. So guys, sometimes you will get nice, pretty whole numbers. That's great. All right? If you get a nice, pretty, perfect square, that is awesome. And so guys, what I want y'all to do now is I want you guys to do numbers 2, 3, 5, and 6. And 6 is a little bit weird. That is the number 17. It just looks really awkward, okay? And so make sure that you guys identify which one is your hypotenuse so that you guys can make sure that you are setting up your equations properly. All right, so we want to identify which one is your hypotenuse, so you're setting up those equations properly. So go ahead and I want you guys to solve 2, 3, 5, and 6, and then once you've done that, you can flip over to the back side of the page and work on the mixed practice there. All right, guys, so just to show you, this is kind of like the intermediate step on all of 2, 3, 5, and 6. I just showed you how I set it up. And then you guys can work on actually solving it. So on 2 and 3, the unknown is the hypotenuse. On 5 and 6, the unknown is the leg. All right, so you can check your answers up here for numbers 2, 3, 5, and 6. For number 2, it simplified nice and into an even number. For number 3, we had square root of 74, which unfortunately you could not simplify any further. There were no perfect square factors of 74. So that we just left it as a square root of 74. And then for number 5, we got x is equal to square root of 300. And we could simplify the square root of 300 into 10 square root of 3. And then for number 6, you got the nice even number of square root of 15. All right, guys, so I want you guys to take a look at these remaining problems. If you need to kind of pause it here, I'm going to freeze the camera so that you guys can be able to check your answers here for these remaining ones. And then, you guys, I want y'all to work on the back page of this worksheet. It's all different mixed practices for your radicals. So I want you to work on the back page of your worksheet, and then once you're done with that, so on the back side of here, it's all mixed practice. We got multiplying, adding, subtracting, dividing, just regular simplifying. So guys, I want you to work on the back page of that while you check. You can kind of check over your answers. I'll leave this up here so that you can see it, and then once you're done with that, you can get to work on your homework. All right.